You think time travel is impossible? Technically, you're doing it right now. Just very, very slowly. Time travel, a dream as old as imagination itself. To move through time as easily as we move through space. To revisit the past, to glimpse the future, to change what once was, or to see what might be. Humanity has always been obsessed with time. But what if it isn't as unchangeable as it seems? What if, just maybe, time travel is possible? To answer that, we must first understand what time actually is. We think of it as a river, flowing endlessly forward. But physics tells a different story. According to Einstein's theory of relativity, time is not separate from space. It is woven together into one fabric, space-time. Every event in the universe exists within this fabric, and its shape can be bent, stretched, and even twisted by gravity and motion. In Einstein's universe, time is not fixed. It depends on where you are and how fast you move. The faster you travel, the slower time flows for you. This is not science fiction. It's been proven again and again. Astronauts aboard the International Space Station experience time slightly slower than people on Earth. When they return, they are a fraction of a second younger than those who stayed behind. The difference is tiny, but real. This is time travel to the future. Not in a dramatic cinematic way, but in the precise language of physics. So, yes, time travel to the future is not only possible, it's already happening. Every moment you move, every time you climb a mountain or orbit the Earth, time bends ever so slightly around you. But what about traveling to the past? That's where things become far stranger. Einstein's equations allow for the possibility of closed time-like curves, paths through space-time that loop back on themselves. In theory, if you could follow one of these loops, you could arrive back at the moment you started. In other words, travel to the past. One idea for how this might happen involves wormholes. These are hypothetical tunnels through space-time, connecting two distant points or even two different times. If one end of a wormhole were accelerated close to the speed of light, time would slow down there due to relativity. When brought back, the two ends would be out of sync. A bridge not only across space, but across time. Step through, and you might emerge years, decades, or even centuries earlier or later. It sounds like science fiction, and for now, it is. Wormholes, if they exist at all, would be incredibly unstable. They would collapse faster than anything could pass through them, unless held open by a substance with negative energy, something we have never observed. Still, the mathematics is sound. Nature may allow such structures. We simply haven't learned how to create or control them. There are other possibilities too. Rotating black holes, called Kerr black holes, could twist space-time so violently that paths through the past might exist around them. The catch? Getting close enough to one would destroy you long before you could make your trip. Even if time travel to the past were physically possible, it opens a Pandora's box of paradoxes. The most famous is the grandfather paradox. If you went back in time and prevented your grandparents from meeting, how could you exist to go back in time in the first place? Some physicists suggest that paradoxes might never occur because the universe somehow, consistently prevents them. You could go back in time, but you couldn't change events in a way that creates a contradiction. You might try to alter the past, but every attempt would fail, as if reality itself enforces consistency. Others take a different approach, the many worlds interpretation of quantum mechanics. In that view, each decision, each event, creates a new universe. Traveling to the past wouldn't change your own timeline. It would create a new branch, a parallel reality where events unfold differently. In one world, you never traveled back. In another, you did, and everything changed. If that's true, then time travel doesn't rewrite history. It just makes more of it. Still, even traveling to the future presents incredible challenges. To move centuries ahead, you would need to travel close to the speed of light. For example, if you flew at 99.999% of light speed, a few hours for you could equal hundreds of years on Earth. This is called time dilation, and it has been confirmed in experiments with particles in accelerators. For them, time slows down dramatically as they approach light speed. In theory, a spaceship could do the same. The crew might experience a few years on board, while thousands of years pass outside. They'd return to a future where everything they knew was gone. It's not fantasy, it's just incredibly difficult, requiring energy beyond anything we can currently produce. There's also gravitational time travel. Near massive objects, time runs slower. If you orbited close to a black hole without falling in, you could experience minutes while years pass elsewhere. This was famously shown in the movie Interstellar, and it's based on real physics. But beyond the equations, there's something deeper. What would time travel mean for us? For memory? For destiny? For free will? If time can bend and loop, are our lives truly linear? Or are we simply moving through one layer of a timeless universe already written in its entirety? Some physicists suggest time might not even be fundamental. It could be an illusion, a product of entropy, the gradual increase of disorder in the universe. We experience time because we can remember the past, but not the future. If the laws of physics are truly symmetric, then maybe time is not something that flows, but something that is. And if that's true, then the past, present, and future all coexist. We don't move through time, we move through perception. In that sense, time travel might not require a machine, but an understanding that every moment already exists, and consciousness is simply scanning through them. So, is time travel possible? To the future, absolutely. To the past, maybe, if the universe allows it. But for now, we are all time travelers, moving forward 1 second at a time, carried by the same physics that governs the stars. And perhaps that's enough. Because every second we live is a journey into the future. A future that we, through curiosity and science, are learning to shape.